We're talking about circles today. That's what it's about. Yeah? So our next lesson's on circles. Okay, you two, Entazar, and Alexis, sit up, please. Entazar, come on. On your graph paper, put 3-12 circles, please. Okay, essential question. How do you identify the vertex, that's not the word, the center and radius of a circle when given the equation? How do you identify the center and radius of a circle given the equation? Book open. Okay, we're going to step back to quadratics for a moment. These are actually related. Quadratics, long time ago, when we first started talking about quadratics, we didn't first start talking about them in standard form. We first talked about quadratics in vertex form. So this was the quadratic in vertex form, the arbitrary case. And vertex form is really nice because you can just look at it and know the vertex. Y equals A times, does anyone remember what goes in the parentheses? X minus, we're getting closer, H, you got it? Squared, what goes after the squared? Plus K. And the H and the K told us something. Lee, do you remember what the H tells us? Okay, Braden's really excited. We'll let him tell us what the H is. Oh, we have a phrase. Opposite, same. Cool. So what do we mean by opposite? What is this telling us? Okay, Fernando, he's back. You can head. McKenna? And by forward, horizontal change, or can we call it horizontal shift? And this guy is the vertical shift. Okay, so the key one I want to focus on is what's in parentheses. When it's in parentheses like that, no matter, well, if it's in parentheses or just in the function, within the function with the x or the variable, it's always opposite. The same rule applies to our circles. Okay, so if you see something inside parentheses with our formula of the circle, you should think opposite. Just like this one was opposite, same. Inside the parentheses, opposite. Outside the parentheses, same. So when we do circles, inside the parentheses, still opposite. Okay, so the equation for the standard form for a circle form of a circle is as follows. Standard form of a circle.
Wait, can you go up?
Sorry. Here we go. Okay, standard form of a circle, you'll still see h's and k's. X minus h in parentheses squared plus y minus k in parentheses squared equals r squared. x minus h parentheses squared plus y minus k parentheses squared equals r squared. When it's in this form, it's really easy to draw the circle. Notice how the h is in parentheses. What's the word we should tell ourselves? Opposite. So our x shift, this is still a horizontal shift. It's the same as the quadratic. It's still, because the x's is our horizontal axis, it's still a horizontal shift. What do we say? Because this minus k is in parentheses. What do we tell ourselves? But it's in parentheses. Opposite. This is our vertical shift, but in this case it's opposite. If it's ever within the function, within parentheses, we think opposite. Is this guy in parentheses? No. So this one's same. So, we get two things from this. The center of the circle. The center of the circle is a point. Opposite and opposite. So it's the opposite of h, comma, the opposite of k. Or if you like to say opposite h, opposite k. And the r, what circle starts with an r? Radius. It tells us the radius. The radius is r. Or it's the square root of the r squared. Because at the end we have r squared. So to find the radius, you have to take the square root of it in order to find r. Okay, so on the side here, I'm going to put example 1. Example 1, we're going to write the equation of the circle. Write the equation of the circle. We have graph paper for a reason because we're going to be graphing these. We have a center at 5, comma, -2, and a radius equals 8. Center at 5, -2, and a radius equals 8. So these go in alphabetical order. X matches with the H. The Y matches with the K, alphabetical order. So if we wrote our equation, we're just going to replace here the H, the K, and the R. So our equation would be X minus, because we do opposite, if H is 5, our equation would be opposite, so let's say -5 squared. That shows you the horizontal shift along the x-axis. Plus, let's do the horizontal or the vertical shift for the y-axis. If it says -2, this is a y, so make sure you do a y. If it says -2 for the center, we think opposite and we write +2 or +2. Make sure that's squared. Now this equals the radius squared. The radius is 8. So if we square it, we get what number? 64. That is the equation of the circle, and in just a sec we're going to draw that. Let me get rulers for all of you to help with straight lines. Three, 4, 5. Take one of these, pass it down. 4, 5. Yes, no, yes, no, so no, and no. Take a ruler, pass it down. Your things, oh, thanks. Yeah. Well, you have like, yeah, you can go now. How long do those meetings usually go? Who's been to their SCOP already, or CCRP? How long was it? Oh, okay. Well, we'll see if it's back before the end of class. Alrighty! What? Depends. It doesn't look like he's coming back. What? It's a meeting with your counselor. They go over, like, college and graduation stuff and see if you're on track with your credits. Oh, and, like, things you'd be good at in life. And your test scores, stuff like that. Alrighty. Now, this is the first day I believe I've ever passed out rulers. There are some rules to the rulers. Some people are already breaking these rules, but I haven't told them you yet. You do not spin them on your pens and pencils. I've nearly had students' forehead sliced by one.
Forehead?
Yeah, because his neighbor was spinning it on the pencil, and it got right next to his forehead. And they have a bunch of them, well, the plastic's sharp too, but a bunch of them have a little metal edge, nearly sliced his forehead. You do not spin them. You do not slap them on the desk. You do not slap each other. Hey, I just said don't do that. Okay, one spin, Raul, and then you're done. Okay, now you're done. That was our one spin for the class. No more spinning. If you want to spin rulers and pencils, do it on your own time outside of my classroom. Okay? Let's graph this. The rulers are to measure things and to draw straight lines. Not to hit each other and not to spin. Okay? Measure things and draw straight lines. So, we are going to graph this, but first let's identify the center. Oh, we already have it. The center and the radius. So notice the center is a positive 5 and the radius is negative 2. So we need to make sure we encompass those numbers. Yeah? The radius squared. 8 squared. With your ruler, you have boxes. Okay, we need to make a graph, negative 10 to positive 10. Okay, so maybe start with the vertical line or the horizontal, which one ever is easiest for you. But right now I need all 4 quadrants. Now with your boxes are kind of big. So we're going to have each box count by 2. Okay? We're going to have each box count by 2. And we're going to take it from negative 10 to positive 10. And I'm going to mark that I'm counting by 2. Negative 2, negative 4, negative 6, negative 8, negative 10. All the way out to positive 10. 2, 4, 6, 8. And with the boxes, they'll be nice because they'll be evenly spaced, and that's really important when graphing. And then we have 2, 4, 6, 8, negative 10. Oops, that's not very even. Oh, man. 8, positive 10, okay? Please number, and each box we're going to have it count by 2 so that our graph isn't huge. Also, if you put arrows on the ends and label your x-axis, and I forgot myself to label my y-axis. Okay? After you have your graph shaped out, you need to go find the center of your circle. The center was 5, negative 2. It was given in the beginning instructions. 5, negative 2. What's our y? No, I think you'll be okay. I think you have enough space. Yeah. Do you need a pencil? Okay, graph 5, negative 2, and just put a nice solid dot there. That's the center. There's 2. Okay, back up. Okay, 5, negative 2 is right here. Oh, but I did 5, negative 4. Whoopsies. 5, negative 2 is right here. That's our center. I'm going to put a little C. That's my center. From the center, every point on the circle is equidistant. Is that correct? Yeah. Is that how circles work? Every point is equidistant from the center of the circle. And we use the radius to do that. So if my radius is 8, I'm going to find 4 more points to plot. Here I am at x equals 5. What's 5 plus the 8 we need for the radius? 13. Oops, I guess we have to extend a little bit. There's 12, 13. So come horizontally, we're adding 8. Go horizontally, adding 8. Yeah, we have to go to 13. Because, yep. We also need to go horizontally to the left. What? No, we're going to do it by hand. You will next semester. So if you have a compass, buy one. Buy a good one, not a crappy one, because the ones I have are crappy. Yep. Okay. Starting at 5, we need to go horizontally to the left 8. What is 5 minus 8? Negative 3. So we come horizontally and we put a point here at negative 3. Okay, we've done both the horizontals. Now we need to do the verticals from the center. What is the y-coordinate of this center point? Negative 2. So we need to do negative 2 plus 8 and go up. Yep, 6. So come up to, there would be 6, go straight up from the center and put your point at 6. We also need to do negative 2 minus 8. Yep, we're going down. What is negative 2 minus 8? Negative 10. And I just realized your graph's going to look a lot better than mine because your boxes are all equidistant. Mine's going to look more like an ellipse because I made my y's not as equal as my x's. So, with your pencil, carefully curve connecting those points. From our 4 outer points, you should make a curve. Because of how I did mine looks more like an ellipse. But you guys have perfect little boxes. Yours should come out like a perfect little circle. Yeah? This one was just labeling a number 6. It just says 6. Okay? And that is a circle. This is no longer a function. Because the vertical line test, how many points do I hit right here? 2. So this is no longer a function. Okay? Circles are not functions. Alright. Let's go do a different type of a problem. Example 2. What is an equation for each translation? We're going to do 2 parts on this. We'll start with this one. Okay. It says, what is an equation for each translation? Catch up, please. And then it says, we have a starting equation, x squared plus y squared equals 1. And it's going to go left 5 units and down 3 units. Before I look at the translations, I want to first decide where this graph is. Can anyone see the center? What number is being added or subtracted to the x? What's in parentheses with the x? Nothing. What number is nothing? 0. So we do opposite, which is still 0. What number is being added or subtracted to the y in parentheses? 0. And the radius is the square root of what's over there. Square root of 1 equals, what's the radius? What's the square root of that 1? What's square root of 1? 1. Now, normally we would say plus and minus 1, but does it make sense to have a negative length of a radius? No, lengths are always positive. Okay, so this is where it is right now. And if we graph that really quickly, just draw a quick little chart on your notes. We have a center at 0, 0. Boys, stop. Shh. Extending from the center, we're using the radius 1. If this is my center, I need to go to the left 1, make a point. From the center, I go to the right 1. Where the rest of the people in class are trying to earn donuts. We're so close. From the center, we need to go up 1. And we need to go down 1. Because of the radius. After you've gone left 1, right 1, up 1, down 1, draw a circle. Now that's the original given to us, but it's asked us to transform it, meaning shift it. We're not done with this problem. This is the original given to us. They asked us to shift it. They want us to shift it left 5 units and down 3 units. Okay, if we go left, a different color. If we go left, that number, if we go left, oh wait. If we go left, that number is negative 5. Do you agree with that? We're at the origin and we go left, that number is negative 5. If we go down from the origin, that number is negative 3, right? But when we write the equation, we have to say something. What's the word we have to say? Starts with an O. Opposite. Opposite. Yes? Sure, no? Sure. Opposite. So instead of, right now it is x plus 0 squared plus y plus 0 squared equals 1. But we don't want to have the origin that wants to shift left 5. So left 5 means negative 5, but we say opposite, and what do we write instead of minus 5? Plus 5. Plus 5. And the y is going to be shifted as well. The y is our verticals up and down, and the y-axis go down 3. So we do opposite when we write the equation. If wherever in parentheses, it's opposite. What number do we write instead of minus 3? So it'll be y plus 3. Now, if you take a circle and you shift it, does my radius change? No, that's a dilation, which we'll do later. If you take a circle and you shift it, it's still the same size circle. So the radius is still going to be 1. This is our answer. And if we graphed it, it's just saying that now the circle, whoops, now the circle has a center, negative 5, 1, 2, 3. It's just been shifted over here. But still the same size, and I didn't draw my scales the same. This circle was just shifted to the left and down. Okay, but the answer it wanted was the new equation with the shifting included. Okay, we're going to try another one like example 2. Same instructions, but a different equation. Example 2, part B. Here's the equation. X squared plus y squared equals 9. We want to transform it so it goes right 2 units and up 3 units. We want to move it around so it's right 2 units, up 3 units, yes? Oh, we're done with bathroom breaks. Class is near the end. Okay. Originally, let's talk about the original before it's transformed. The original center. Opposite, opposite. What's the x-coordinate of the center? What's being added or subtracted to this x in parentheses? 0. What's being added or subtracted to this y? 0. And the opposite of 0 is still 0. If there's not a number with the x squared and y squared, it's really nice. It's at the origin. The radius has to be the square root of that number. The square root of 9. I don't know who this is. It's 229. I'm 129. Yeah. Okay. It's been happening for a couple days. Sorry. I think the secretary's writing wrong room numbers because I keep getting these notes for students I've never met. Okay. Let's try this. The radius is always the square root of that guy. What's the square root of 9?
3.
Normally it would be plus and minus 3, but with radius, since it's a length, we don't have negative lengths, so the radius is 3. Now if we shift the circle around, is it going to change the radius? No, the radius will still be 3 in our new equation. But what changes is the h's and k's. The vertex change, not the vertex, sorry, the center changes. Okay, if this says right 2 units, you're at the origin and you go right 2 units, what number are you on? X equals 2. So that's a positive 2. If we are at the origin and we go up 3 units, what number are we on?
Positive 3.
Y equals positive 3. So when we write our equation, we think those, but we say opposite. Okay, there's going to be something squared plus something squared equals a radius squared. Who can tell me what goes in the first parenthesis? Raul? Okay, that's beginning, Raul. X involves this. The X is your right and left. No, it is plus 2. We say opposite, so we do minus 2, and that needs to be squared. Okay. Kara, can you tell me what goes in this parenthesis? No, the first one's X, the second one's going to be, Y. And did you do opposite? I didn't hear the other part. Minus 3. Okay, so the first one's X, the second one's Y. And you always have to think opposite. Now the radius, we've already discussed, the radius doesn't change. So what number do I put here? 9. It's the radius squared. So this number matches. Because it'll be 9, which is the radius squared. Okay? Let's practice graphing this one. Now we have a center at, if it's ever in parentheses, we think opposite. So this one's opposite, opposite. Gerardo, what's the center point? Opposite, opposite. So it would be 2, 3. And our radius is the same as above. The radius is the square root of 9, which is positive 3. So we're going to graph. If you would take your ruler and make some straight lines. I think on this one, since the numbers are small, we'll be okay to, we need to take it to at least 6. Well, you might want to choose to make each box counting by 2. I'm going to make mine even this time. 1, 2, 3, 4, 5, negative 6. 1, 2, 3, 4, 5, positive 6. 1, 2, 3, 4, uh-oh. There's my 6. Hopefully I don't need more than that. The first thing you plot is the center. Would you go and plot your center point? 2, 3. I took all of my axes out to positive 6 and negative 6. The reason I know it's going to be something involving a 6, because the biggest number in my center is a 3, and my radius is a 3. So I went 3 plus 3. I figured out something's going to be a 6. Okay? Starting with your center point. 2, 3. I'm going to even put a little C so I remember that's the center. Yep. Because we go right 2, up 3. From the center, we need to move 4 directions. How many units do I move to the left? 3. So if I'm here, I just go over 1, 2, 3. Except for I'm at 2, and 2 minus 3 is negative 1. Now I need to go to the right. How many units from the center? 3. If I'm at positive 2 and I go right 3, good, positive 5. Right here. I also need to go up 3. If I'm at a height of 3, I need to go up to positive 6. If I'm at a height of 3, I need to go down to 0. Once you have those 4 points marked, you can then connect them with a nice curved circle. I missed a little bit. My shadow got in the way. Okay? You have graph paper for a reason. Make sure it's nice and neat. Okay. The last one, I'm going to give you a graph, and we're going to write the equation by looking at the graph. Okay, so if you need to flip to the back, I'm going to give you a graph. I'd like you to copy the graph. Example 3, given the graph, write the equation of the circle. Given the graph, write the equation of the circle. I'd like you to copy down the graph. Medium-sized. Let me graph it first, and then you can make it match, okay? Let's do this one. Nope, I don't want to do that one. Let's do this. Shh, guys. Hold on just a minute. I'll have the graph done in just a minute. I couldn't imagine a family road trip with all of you. Shh, turn around, please. Oops, that's not very centered, is it? There's a poorly drawn circle for you. Okay, let me tell you what these points are in case you're trying to eyeball them. This is -5, 1. Okay, this is -3, 3. This is -3, 1. Yeah, really you just need the quadrants 2 and 3. This is -1, 1. Graph those. I want you to try to write the equation of the circle. Remember, the equation of the circle follows this form. Where H is a horizontal shift, and we think opposite. K is a vertical shift, and because it's in the parentheses, we think opposite. And R represents the radius, but on the right side it should be R squared. I want you to try to write the equation of the circle, please. You're going to do it first by yourself. The good news is it's due after the test, right? Yeah? Okay, hurry. Alrighty. Who has the, careful, who has the equation? If it is correct, maybe you'll get an extra donut. Who has it? We still have, guys, we still have to survive 14 more minutes being good, right? And dessert turnaround. I need the equation. Who has it for an extra donut?
Wait, I think I have it.
What is it, Raul? Nope. Okay. Who has it for a donut? Okay, Brayden? Okay, Brayden, why don't you come write what you're saying so I don't have to figure out what you're saying. So I don't just say no because I didn't hear a special word. Well, it didn't start with a 5 though. It does start with an X, but there's...
Yeah, but I got my push down.
Okay, let's see. Make sure everyone takes 2 pieces of graph paper for the homework.
Oh, dude.
There, give me one of those if you would. Here it are now. Now you get 3. Okay, let's see. If the graph paper hits the end of your row, hold up the extras, please. I'll come get it. Okay, go get the extras. Any extra graph paper in the front? Let's see. Okay, Fernando has verified, but before, I need you to be quiet. 10 more minutes, guys. Smelling those donuts already. Just 10 more minutes. That's all we need to survive. Yes, it is 2014. It's almost 2015, so don't get used to that. First, we need to identify the Alright, guys, you're killing me. Alright, Johnny. What are the coordinates of this vertex? I said vertex. Why keep doing that? Quadratic formulas. Too much. Center. Thank you. Johnny, what are the coordinates of the center of the circle? Good. So. Oh, Brady, you're so close. I think he might get a donut for effort. Who gets an extra glass of milk with a donut? Brooklyn? What do you mean switched around? Okay, nope. Okay, Raquel? What is it? Okay, shh. Guys, come on, please. I so want to get these for you. It's 9 minutes. You can do it. 9 minutes. Shh. Johnny. We say opposite, right? Ray, you're so warm, so I'll give you a donut for being so close. -3, but we say opposite, and we write +3, like Raquel said. So x plus 3. We're not done.
And then you put y.
Sergio, Gerardo. And then Raquel. So we say opposite, and be y minus 1. And the radius, let's see if he was thinking right about the radius. Is that 2? Is that 2? Yes, it is 2. I don't know why you're all saying no. But in the equation, it's supposed to be radius squared. So we would write 4.
No, right.
Who got this one? Did anyone? Okay, good. Raquel and Brayden, remind me next time. An extra donut if the class can behave themselves for 7 more minutes. It's getting a little wiggly. I don't know. It's getting a little wiggly. If you have a homework planner, which all of you should, or a way to write down your homework, let's write down an assignment. Next time is the test. Circles are not on the test. Okay? Circles are not on the test. So this circles assignment is due, say Tuesday? So Thursday is the test. So this circles assignment is due on Monday. Your main priority is to study that study guide, that blue review. And then after the test, then I would probably start working on the circles. Okay? 2:33 it is. We are going to be doing, you have graph paper for a reason. Please make your graphs neat. Just a minute, please. Okay, we are going to do 2 through 22. Okay, Brooklyn, you have a question? Depends. I would rather do these circle questions we'll do after the test. I just want to make sure we give you enough time on the test. And if people finish and we have time, then short. Okay? We are done with notes. But there's a question. There's 2 questions. I need to... Guys, kill me. It's all. So there's 21 problems. All. Okay? Yeah? Darnell, you should study the first time. That blue packet is your golden ticket. That blue packet is your golden ticket. I've got a golden ticket. Have you seen Charlie in the Chocolate Factory? Cheer up, Charlie. Oh yeah, passing the rulers. Hey, Antazar, come here. Come here. Come here. Passing your rulers to the middle aisle, please. Intezar is coming around to pick them up. Okay, you have graph paper, please use it. Please number the axes when you graph. Time.